All right, so proportional relationships can be represented in different ways. We're going to look at the equations below, and this is something we haven't done before. It's just looking at an equation and figuring out if it is proportional or not. So looking at these three equations, y equals 4x plus 2, y equals 4x, and y equals x, which equations do you think are a proportional relationship, if any? What are some things we notice about the three equations? What are some things you notice about the three equations? Are we sleepy this morning? All right, they all contain a y and an x value. Jada says, yes, I'm sleepy. That's okay. Okay. Do we think any of them are proportional? Okay, Nathan thinks that y equals x is not. Nathan, why do you think it's not proportional? Okay, it doesn't show a number. Are there any others that we think are not proportional? All right, so when we are looking at equations to figure out if they are proportional or not, what we're looking for is, are they in y equals rx form? Are all three equations in y equals rx form? All right, let's look at the first one. We have our y value. We have 4, which would be our r, x, but then we have this plus 2. Does our equation for proportional relationships have a plus or minus back here behind it? No, it does not. So if you are asked is the equation proportional? If it has plus a number or minus a number, it's an automatic no. It is not proportional. Because if I were to graph this, it would cross through the point y equals 2, and proportional relationships have to cross through the origin. and this one, 4x plus 2, would not. So this one is not proportional. All right, what about y equals 4x? We have y, we have our r, and we have x, and nothing else. Is that one going to be proportional or not proportional? Right, it is going to be proportional because it follows our y equals rx formula or form. All right, so y equals 4x is proportional. If I were to graph that, it would go up like that. Okay. That's not a straight line, but that's okay. And let's look at the last one. Y equals x. Proportional or not proportional? Nathan's already said not. Monica says not. Okay. So I'm going to, and I'm not going to draw this line. I'm going to put a line in here. So y equals x would look something like that. Is that proportional or not proportional? Is the line on the graph proportional or not proportional? Gabriel says proportional. Why is it proportional? It's a straight line and it goes through the origin, which are the two requirements for a graph to show a proportional relationship. So I understand why when we look at this, we say it's not, because we don't see a number here before the x. Whenever we have y equals x, it is the same as y equals 1x. We just don't write the 1. So if you see y equals x, it is the same as y equals 1x. So 1 times whatever the x value is. So if I put 1 in for x, 1 times 1 equals 1, so y equals 1. If I put 2 in, 1 times 2, so y equals 2. So don't get tripped up by that. If you see y equals x, it is a proportional relationship. Any questions about those? Okay. All right, let's move on. All right, so in a video game, for every 3 coins you collect, you earn 4 points. Create a table of values to represent the relationship. We're going to graph it, and we are going to determine the equation. So I have a table over here. 3 coins is 4 points. And I need to figure out what my constant of proportionality is. I'm going to skip right to C and do my equation first, because that is going to help me with filling in my table. So remember, to find constant of proportionality, we take y divided by x. So I'm going to do 4 divided by 3 equals r, and I can leave it just like that as 4/3, or I can write it as 1 1/3, or I could do it as a decimal, 1.333333. It's just easier to leave it as 4/3. So remember, y equals rx. We know r is 4/3 x. So this is my answer to C. Y equals 4/3 x. We've been practicing that for a few days now. Now I'm going to use my equation to fill in my table. So coins is my x, points is my y. So my first x value that I have is 1. If I put 1 in for x, I would have y equals 4/3 times 1. And what is 4/3 times 1? What is 4/3 times 1? 4/3. So my missing number here is simply 4/3. 1 4/3, 1 and 4/3, that ordered pair, that is my unit rate. So for every coin I play, I earn 4/3 of a point. Excuse me. All right, now we're going to use it to do our other one. So y equals rx, which is 4/3. And I know my y value, but I don't know my x value. So I'm going to substitute 12 for y equals 4/3 x. And remember yesterday, we talked about how 4/3 x is the same as taking 4/3 times x. To get x by itself, we have to do the opposite operation of multiplication. So what is the opposite operation of multiplication? Division. So I'm going to divide this by 4/3. And what I do to one side of my equal sign, I have to do to the other to keep things balanced and proportional. So 12 divided by 4/3. We're going to do keep, change, flip, and I'm going to change my color here. So keep 12, change division to multiplication, and flip my numerator and my denominator on my second fraction here. So 3 becomes my numerator, 4 becomes my denominator. And now I can just multiply. So 12 times 3 is what? $36. And 4 times 1 is 4. And if I simplify that, 36/4 is what number? Nine. So to earn 12 points, I have to play 9 coins. Any questions about how I filled out the table? So the last part that you have is to graph the relationship, because we did A and C. So now I'm going to graph these. And we have 3, 4. What in the world? We have 1, 4 divided by 3. And we have 9, 12. So if I zoom out a little bit and I take a line, we can see that it is indeed a proportional relationship, that it goes through the origin is a straight line. Now, whenever you guys graph, remember you're going to want to go to the resources link on the math homepage and click on the Desmos graphing calculator. If you have a question, you have to graph. One of your assignments today does ask you to graph, and the link is in the assignment. You just click where it says Desmos calculator and you can access the calculator there. Any questions about graphing? All right, let's do one more. Oh, this one's real tiny. All right, we have a graph here, and it says 3 toy cars raced down a straight path. The distance each car traveled in meters over time, measured in seconds, is shown on the graph. So the first thing I want to notice is that time is my x, and distance is my y. So this is y, this is x. And since it's a little hard to see. And I have 3 different cars, A, B, and C. And these graphs represent how far the car traveled in a matter of seconds. So our first question wants to know, at what speed is each car traveling? So if it says, at what speed is it traveling, we want to know meters per second. So that is our unit rate. So we're going to start with car A. And I'm going to find a perfect point. So I see a perfect point at 2, 1, 2, 3, 4, 5, 6. So 6, 2, because 6 is my y and 2 is my x. So what is 6 divided by 2? 3. So car A is going 3 meters per second. I'm just going to leave an S for second. All right, let's look at B. I see a perfect point at 3, 3. And we know that any number divided by itself is 1. So car B is going 1 meter per second. And now car C. I'm going to have you guys do this one. I'll give you the point, and you tell me how fast it's going. 1, 2, 3, 4, 5, 6, 7, 8 for my x, 4 for my y, so 4 over 8. So how many meters per second is car S going? Or car C, sorry, not car S. How many meters per second? 4 divided by 8. Check that again. Remember, we're doing 4 divided by 8. And Monica says a half. 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 Because we know 4/8 is an equivalent fraction for 1/2. So 1/2 a meter per second. So looking at our unit rates, our constants of proportionality, which car is traveling the fastest, A, B, or C? And I want you to tell me why. So if you think it's A, why do you think it's A? If you think it's B, why do you think it's B? Okay. So Monica says C because it's the shortest. Nathan says A because it is going more meters per second. Gabriel says A because it has more meters per second. All right, so if we hadn't done this work down here, where we figured out the unit rate or the constant proportionality for each line, if we just looked at the graph, would you still say that A is traveling faster? Why not? Okay, because B looks farther. So remember that our distance is our y value. So A is at the very top of my graph. And I'm just going to trace that line all the way down. So when car A is at 15 meters, how far had car B traveled? When A is at 15 meters, how far had car B traveled? Only 5 meters. So which is greater, 15 or 5? 15. Now, if these two values, our distance and our time, were swapped, then no, A would not be the fastest. But because of the way our graph is, A is traveling faster. We can tell that by looking at the graph and seeing that it has traveled farther in fewer number of seconds than the other two cars. Does that make sense? Any questions? Not seeing any questions pop up. Okay, so let me share Canvas if I can find it. There it is. All right, so for today, You're going to have 2 assignments. The video from this recording, I am going to go ahead and post here where it says representing proportional relationships, so that you'll have it to refer back to. And then you have the 2 assignments. The first one is a Google drawing, and it is moving really slow. There you are. So there are 2 parts to this when it loads. The first part, you have to fill in the table and then give me the constant proportionality and the equation for the relationship, and same on the second part. Fill in the table, give me the equation, and tell me what the constant of proportionality is. You also need to tell me what it means. So if we are measuring a car's speed in meters per second, you would say that 3 is how far car A, or 3 meters is how far car A can travel in 1 second. That is the explanation for that. And then the last one is weight on the moon. And this has multiple parts. You are going to read the word problem and then answer the question. It wants to know, it wants you to define the variables. So remember yesterday when we defined variables, you have to tell me which is going to be your X value and which is your Y value. So you have weight on the moon and weight on Earth. You need to tell me which of those is X and which of those is Y. And then write an equation. And then you are going to tell me what the constant proportionality is and what it means. And then you have a chart. Let me pull this assignment up here. Let me make it bigger for you. So here's the first slide. Tell me what is the X value, what is the Y value, write the equation. What is the constant proportionality? What does it mean? Then you're going to fill in the table down here. And here is that link to that Desmos calculator that you are going to put your points into. And I want you to screenshot your graph and add it to this slide before you submit it. Are there any questions about the assignments you have for today? If you have no questions, as always, you can stay signed on to our meeting link here, or you can sign off and jump back on.